This conference will now be recorded.
Okay. So I'm going to define the agenda for today's class. So the first one will be we're going to look at the small case on PCA. How do we really use PCA when we start creating predictive models? So we've understood the theoretical part behind it, right? Yesterday. So we understand what does PCA do, what's the math at the back end, how exactly are the principal components getting created. So we just have to use it once, in some case, so that you get a better hold of what do you mean by PCA. So that will be for the first 15 to 20 minutes, if I'm not wrong. And post that, we're going to, start off with a lighter topic, basically Tableau. Okay, so we're going to be, discussing about this business intelligence tool, something called Tableau. So I hope everybody has installed Tableau. So if anybody who hasn't done it, you still have another 15-20 minutes, because I think parallelly, let's have it more like a hands-on sessions. You can keep trying something at the back end, and you can, let me know if you have more questions. So this is the link. Okay, I want you all to just go back and download, let's say 10.1 version. So I'll tell you why specifically I'm talking about 10.1. You just get to use more other versions here, but why specifically 10.1? I'll tell you once in some time. So if anybody who hasn't done it or were not part of yesterday's class, please go ahead and do that. So the link is there in the chat box. Just go back and download 10.1 version and install it. It shouldn't take not more than 5 to 10 minutes for you to do it. Or do you have a good broadband with you? Okay. So now jumping into the topic. So I think in yesterday's class, we started off with something called PCA, right? Just give me a minute. I'm just opening the book. Yes. So I think in yesterday's class, we started off with something called as PCA, right? So what do you mean exactly by PCA? PCA means principal component analysis, right? So we understand that PCA is kind of a variable transformation, algorithm. So it's more like what? It's more like an exploratory tool. So what happens is that, guys, typically when somebody is sharing us data sets and they want us to probably create some predictive models on those, one of the very first questions that you'll ask is, hey, how many features do we have here? How many variables are we probably using in our predictive model? Is it 200? Is it 300, 400? I'm okay. But is it something like 500 or 1000 goes on like that? Then it might probably be a problem for us. So we call this problem here in modeling as something called curse of dimensionality. What do you mean by curse of dimensionality? It means I have too many variables for me to create a predictive model, which might make my predictive model to become very unstable. Why would I call it as unstable? Because there are going to be too many coefficients that he'll have to estimate, which means he might have not understood the relationships properly. The coefficients might probably get inflated a lot. So the model is going to turn out very what I would say is unstable here. And sometimes you may not be even be able to create the predictive model because your algorithms doesn't have enough capability to estimate it, or probably you don't have a system which is enough capable to probably estimate it, right? So the problem is that, guys, when you have too many variables with you, it's going to become a very big problem. Why? Because you can't create a model practically, or even if you're going to create it, there are too many coefficients. A lot of instability is what we're going to see here. So then what do? We basically start using a variable selection method or a variable transformation, or more like a reduction method to solve this. So what do we have? We have two methods that we can do. Either we can use a variable selection method or a variable reduction method. What is a variable selection method? You just go back and check if the target and the predictors are related or not, right? So I think we did write it somewhere here. Everything. I don't know where did it exactly go. Okay, so but we do understand, right, that it is nothing but so I think it's here, a variable selection method where you go back and test each and every predictor variable against the target. You just retain the predictor variables which are very important. But in variable reduction, what do? We leave it to a mathematical transformation to transform our entire data, And that transformation will just give you a few number of variables. It may not give you, the high number of variables that you originally had. It's going to give you fewer number of variables right now. One in that particular class is somebody called PCA. So what exactly is PCA doing? A PCA is exactly introducing something called principal components. It's doing something called a varimax rotation, and then it is giving us the features where there is maximum variance. And instead of using our original features, we'll start using the principal components. Where do the reduction come in place? The moment you start deleting one of these PCs, we do delete the PC which is having the least variance, right? So this is exactly what we discussed, and we understand the math at the back end. What do? We come up with the variance covariance matrix. We do a eigenvalue decomposition. Why? Because the eigenvector will tell you which direction there is maximum variance. Eigenvalue will tell you how much of variance available. With that, you go back and convert your original features to principal components. Then you just retain the principal components, which are very, very important, or people who have the highest variance for us. So this entire procedure, I think we have pretty much discussed in detail yesterday. This procedure is called as a principal component analysis, where the data is naturally getting kind of transformed here. Right? We are doing a transformation from the original data set with these two variables. We are coming up with a transformed data set with different principal components here. So what exactly does a PCA play a role in modeling? So what is a PCA actually going to do? So as I keep repeating, guys, when you have an input data set, probably let me assume that there are 1,000 variables with you, right? What you can do is you can apply a PCA on top of these 1,000 variables. That is, you can do a principal component analysis on top of these 1,000 people. The result of the PCA is probably a new data set, which might have, let's say, 50 variables, shall we say? Probably 50 variables. So the input data set, let me call it as a training data set. Somebody, is sharing a data set with you today in the month of June. Okay. And what you're doing is you're making use of this data set. You're applying a PCA on top of it. You get a transformed data set. This transformed data set is not having 1,000 variables, but probably a reduced number of variables, which is 50. These 50 variables, along with the target, so the target is separate, right? So I'll call it as a 51st guy, because only predictors are used in principal components, right? Principal component analysis. The target is kept aside. You don't involve him in principal component analysis. It's only the predictors. Now what do? We create a predictive model on these 50 principal components, and the model is ready to get deployed. So what are we going to do? We're going to deploy our predictive model now. Now let's say, guys, in the month of August, okay, probably somebody is giving you a new data set. They are saying, hey, you've already created a predictive model, right? I've got a new cohort of data right now, let's say. I want you to predict what is going to be the target right now. You want the model to do its prediction. So what do you have to do? You have to make use of the model which has learned on the 50 principal components that we already have, right? So we already created 50 principal components using the training data set. The model learned on this 50 principal components, and then this model was deployed. Now we are saying, hey, you're in the month of August, there is a new data set for you. Now tell me, guys, what do you think you'll probably do with this data set? Do you think you can directly feed it to the predictive model, or what would you probably do? Do you think directly passing it to the predictive model will work? What do you guys think? So using a training data set, you have created your principal components. Using those principal components, you created the predictive model. You have deployed the model. Now you're getting a new data set. You're in the month of August, okay? There's a new data set and your boss wants you to predict for this data set. So my question is simple. Do I directly send this data set to the model? Will he understand it? Or what should I probably do if you think he's probably not going to understand it? What do you guys think we should probably do here? Yes. So I think I've got a couple of answers. Okay, good. So I think the natural answer would be that you can't pass the new data set directly to the model, right? Why? Because the model has got created only on 50 variables. That is PC1, PC2 goes on up to 50. He understands only 50 columns of data, right? But what you're having here is probably 1,000 columns of data. But your equation is having only 50 coefficients. 50 coefficients for 50 variables. But here you're having 1,000 variables. So how can 50 coefficients handle 1,000 variables? So you can't be sending it, right? So the answer is obviously no. So I understand that you guys are all telling me that the answer is no. Okay. So what do I probably have to do if I can't send this data set directly on the inside? So one, I think, most of you are telling me that, to go with the PCA again. So everybody is saying that we need to go with the PCA again, which means you're saying that take up this new data set, apply principal component analysis, which will give you a variable, a data set with 50 variables, pass this data set to the model and get your predictions. Is this what you guys are telling me that we should be doing? Take up the 1,000 variable data set, create a PCA model again on top of this guy, bring it to 50 variable format, then push it to the predictive model and get the prediction as a result. Is this what you guys are telling me to do? Okay. Who else is saying yes? Okay. Everybody is saying yes? Good. Okay. So let me ask you all a question, okay? So the question is, here guys, my training data set is here, okay? So what is he saying? My training data set is somewhere here, and let me assume a test data set, okay? Two variables, I've taken my test data set. The test data set looks something like this, okay? So this is my training data set on which the model was created. This is the test, which is basically the test data set on which the model is about to be predicted on. So you guys wanted me to do a PCA here, right? Because 1,000 variables is not good enough. So let's say for an example, guys, you got one PCA at this direction. Probably it is at a 45-degree angle. So one PCA you've got here, another PCA will be at 90 degrees to this guy. I hope everybody understands that. So we have got a PCA which is at a 45-degree angle here. Here what you get, the PC, it is probably at a 25-degree angle or something, right? So now see guys, I have a very simple question to ask you all. So here the input data set was passed on to PCA. Here he's saying, hey, the first principal component was created at, let's say, a 45-degree angle. Okay, so this is what? This is a 45-degree angle PC. The model is able to learn on this characteristic, that is a principal component which was created at a 45-degree angle. Now probably you're having a principal component that you've probably created which is at a 25-degree angle right now. And this principal component is getting passed on here. Do you guys see that there is something going wrong here? Do you see something that's probably going wrong? Because I see something. Do you guys see that there is something going wrong here, or are we still correct? See guys, so the point here is you shouldn't be creating a new principal component analysis model on the test data set again. We shouldn't be doing that. So what you're doing is you're saying, hey, this was a training data set that somebody had given to me. Okay, we are doing a transformation on that training data set. And what was the transformation? We said, hey, let's turn the data set at a 45-degree angle. So input data set was turned at a 45-degree angle. That data set was used in the model creation. Now, if there is a new data set that somebody is going to give us, tell me guys, does it make more sense to do the same kind of a transformation on the data set also? Or do you think you should be doing a altogether different transformation on this data set? So I had a photograph. The photograph was basically transformed at a 45-degree angle like this. So now the model has learned on these kinds of photographs. Now probably you are passing a photograph now which is transformed at, let's say, 135-degree angle or something. Do you think the model will be able to perform or predict properly on this kind of a data set? The answer is no, right? Basically, the transformation that was used on the training data set should be exactly used even on the testing data set. Because the model had worked on a data set which went through this transformation. So you can't use a test data set which might go through a different transformation altogether. No, that's completely wrong. Any transformations you have done on the input data set, the same set of transformations should be done even on the test data set. This is a very, very important point, a very common logic or a common sense that most of the people miss out. I've seen a lot of people make this mistake. You shouldn't be doing it, guys. The same principal component model that was used on the training data set should be used on the testing data set, which means I should be still creating my principal components at the same transformation I did on the training data set. It should be kept, constant. It should be held constant across any kind of a data set that you will meet tomorrow. Now go back, guys. Let's look at the small case. See here. We're importing all the necessary libraries we want. We are importing a data set, something called a German credit data set. Okay, it's a pretty old one, but a pretty interesting one. You have a lot of features saying, how much of credit memo, debit memo that each of these accounts are having, how many months on loan duration, is he a foreign worker or not, how many, let's say, dependents does he have. So there are a lot of details about each and every account that you can see. And we have the target which says default or not. Okay, whether the customer defaulted the loan or did he not default? Was it, probably a riskier loan? Did he have troubles paying back the loan? Yes or no? That's the default account. So we should be creating a binary classification model here, right? So what I will do is, guys, first we will split the predictors and targets separately. So we're saying, hey, target is nothing but the default column. So drop only that column, which will become my X, all the predictors. So you can see 1000 rows of 20 columns. Whereas the Y will be a single column, which is only the default. So 0 means, probably did not default. 1 means, yes, the customer did default. So capital X is 20 predictors, while this small y is basically your target. I'll call it as capital Y itself. Capital X is predictor, capital Y is target. Now what we will do is, guys, we'll go back and fetch only the numerical columns first. Okay, or let's say we'll do it for categorical columns first. Okay, so what we will do is the standard scalar should go here. Now we are doing something called label encoder. Okay, so what we're going to do is, guys, we're going to fetch only the categorical columns from this data set. Why? Because if you look at the capital X, right, you have string variables in each and every column. It is actually categorical in type, right? But it's all string. It's saying, hey, less than 0 debit memo, 1 to 200 debit memo. This is something the model cannot understand. So instead of these things, you should basically keep it as zeros and ones, which means you need to encode them as numbers. We'll choose only the categorical columns right now. So these are all the categorical columns. Okay. We are importing something called label encoder. So from scikit-learn.preprocessing, import label encoder. From scikit-learn.preprocessing, import standard scalar. One is for categorical, another one is for numerical. Now we'll say LBL is equal to label encoder. So we are saying, hey, create a label encoder instance. take up each and every predictor, which is categorical in nature, and apply this transformation. That is, learn the different levels on the inside and convert them as numbers. So let's hit Control Enter. Let's go back and look at it. You can see it's no more strings, it's basically numbers. All the strings have got encoded as numbers. Now we will fetch only the numerical columns separately. These are the people. These numerical columns are going to get standardized, x minus mu by sigma. So we will say, hey, standard scalar, S is equal to standard scalar, fit transform of this entire data. This becomes your numerical data set right now. Everybody has got transform. Everybody will be running right now between, let's say, -1 to +1 or -2 to +2, -3 to +3, we never know. So categorical columns have been handled and numerical columns have also got handled. Now we are just merging them all together to create your final capital X. Capital X is right now what? Once again, back to 1000 rows and 20 columns. What is your capital Y? It is your single target column with which you need to create your predictive model right now. Now look at this case, guys. Even here, there is a small catch, okay? We're going to come back in a minute. Now look at this case, guys. We're going to import the train test split function. We are splitting the predictors and the targets as predictors for train, predictors for test, target for train, target for test. Then what we will do is we'll say, hey, from scikit-learn.decomposition module, can you please import PCA? Okay. Now we will say, hey, create a PCA model. Probably we'll create 10 principal components. So we're saying, hey, I don't think 20 variables are good enough. It's probably, too many number of variables to create a model on. So let's do a PCA and end up with only 10 principal components right now. So let's hit Control Enter. Look at this. You can see a PCA model is going to get created with 10 principal components. Now what we will do is we'll say, hey PCA, can you please learn what are the eigenvalues and eigenvectors and even transform this data set itself in that particular direction? We're saying what? Hey, on the training data set, you can learn what is the eigenvalues, eigenvectors, that is a direction where there is maximal variance, and also please transform that particular data set. So the data set which was looking like this, guys, now post the transformation, you can see is going to look like this. Can you see? Everybody has got transformed. Now what we can do is we can go back and ask, hey, can you please let me know what is the amount of variance explained by each and every component? Let's hit Control Enter. You can see the first guy is going to give you 29% of the variance, second guy 14%, third guy 7%. Let's find the total. We are capturing almost 85% of the variance that was available in the original data set. Literally 85% was retained. Only 15% is the loss. Now you can go back and try. Okay, how about for 8 components, what do we get? So, okay, X train, I need to run it from here. Okay, so for 8 components, what do we get? We get 78. So for 2 components that you're losing 7% of the variance. So you have to make a decision. Is it okay or not? Then you may probably think, okay, how about 7 components? Do 7 components do a good justice? 74. 74 is still okay. You can probably keep it as 5 components only. 5 components is giving you 65% of the variance. So now you're saying, okay, I think it's bad. Let's go back to 8 itself. So you can choose. Similarly, you can start off with 15. So now you're saying, hey, I want 15 components. 15 components is giving you 97% of the variance explained. You can then try for 13. For 13 components, how much of variance? 93%. Then you can try it for 11 probably. For 11 components, how much of the variance is explained? 88. So now you can decide, okay, I think 11 is good enough. I'm still getting probably 90% of the variance or something. So using the amount of variance explained and using the idea of how much you're ready to lose as patterns, you choose those number of principal components. So here we are saying, hey, 10 principal components is what I want. So now you can see, guys, this capital X was the original data set we started off with 20 variables. Now we are ending up with what? With x underscore train, which is having only, I need to make it as a data frame so that, or let's do something like x underscore train dot shape. Okay. So now you can see that you're going to work only with 10 of those columns right now. So x train was what? X train was originally having, while you originally created this data set, right? X train was probably having 800 rows, but 20 predictors. But post doing the PCA, you can see it is 800 rows and only 10 predictors, only 10 principal components. And how much of variance is explained by these 10 principal components? Literally 88% of the variance. Now let us import support vector classifier. We'll say classifier is equal to SVC, open and close bracket. Now we will say, hey, using these 10 principal components, create the predictive model against this target here. So the model has got created right now. So what did you do? You have basically done this portion where you got the data set, you had 20 columns, you converted them as 10 columns, and you've created the model on these 10 columns right now. So the model is ready. So let's say you're waiting up to August. In the month of August, somebody is giving you a test data set. They're asking you to go back and predict on this test data set. But test data set is having what? 20 columns, right? So if I go back and say, hey, classifier, can you please predict using this x underscore test? He'll give you an error. He's saying what? Hey boss, I see that it is 20, but ideally it should have been only 10 because the number of features that I used at the training time was only 10 features. But probably right now you're giving me 20 features. So it doesn't mean that I can pass the first 10 features. That's wrong. Because it's still a raw thing. It's not yet got converted as a principal component yet. So what you need to do is, guys, you have already created the PCA model, right? On the training data set, you would have learned all the eigenvectors, eigenvalues, etc. Right? I think you can even access them if I'm not wrong. You can get the now components. The eigenvectors is not there, but anyways. So these components, these will give you the principal components, right? So you can access the principal components. That is the direction where it is actually moving. So the PCA model has already got created on the training data set. All you need to do is you need to keep a copy of it in your system. Say for an example, I can help you out understand this. So we can say, okay, it's a function called from scikit-learn.externals, I think. Okay, import joblib. Okay, joblib. Now you can say, hey, joblib, I want you to dump my model. Dump whom? Dump my PCA model I've created with what name? PCA for train that I created in the month of June. Dot joblib file. So you can just dump it here. Let's go back and look at it. So at this particular area it would have got saved. I can probably save it in my desktop. Okay. So what we'll do is we'll dump this particular PCA model on the outside. So you can go back and check. Okay, the PCA model would have got created. Can you see? So the model has got saved in your hard disk right now. So a joblib file, it's called a joblib file. You're basically saving the model in the month of what? June 09. Similarly, you can save your support vector classifier also. So I can just go back here and I can say, hey, please, save my support vector classifier also. So this is the classifier. We will save that guy. We'll say, hey, he is my SVC that I've created. Let's hit Control Enter. Even the support vector classifier would have got saved at the backend. So you can see. So both of them have got created, right? So both of them have got saved inside your system right now. Now, say for an example, you are right now in the month of August. So let us assume you are in the month of August. Okay, you are asked to do some prediction. So what we will do is we'll go back and import all the data set that somebody is sharing with us. So this is the data set that they're giving us. You should do the same transformations, guys. Example, it starts here. Even the label encoder you should save outside. Even the standard scalar you should save outside. Everything should be saved. Okay, this is a very important topic, guys. See here. So what is plain y, small y, it's capital Y, right? Still small y, capital Y. Yeah. Okay. So you can see right now, there are many models you have created. One is you created one for label encoder. This is something you need to save. You have created one standard scalar. This is also something that you need to save. Then you have created a PCA. This also you should save. Then you have created a predictive model. This also you should save. All the 4 people should be saved. So let's do that. 1, 2. So next one is what? It's your LBL. We'll call it as LBL, label encoder. Next is SC, that is your standard scalar. So let's have all this. 1, 2. Okay. So first this guy, second, third, fourth. All the 4 people have got saved right now. Okay. So yeah, here they are. So these are the 4 models you have saved outside. One is label encoder. That is, he would have learned, right? That, okay, if it is male, I should code it as 0. If it's female, I should code it as 1. So that is also learning he has done. So you need to know, okay, which guy was coded as what, because you can't exchange it on the testing data set. So that has to be saved. Then standard scalar. On the training data set, you found some, mean and standard deviation. The same mean and standard deviation should be used even on the test data set. So you're saving that guy also. Then PCA. So he has learned certain eigenvectors on the training data set. The same PCA should be used even in the test data set. Then finally your predictive model. The predictive model also you should be saving it outside. Now what you will do is, guys, tomorrow when you get a new data set. So this is a new data set that somebody is sharing with us. Okay. Let's go back and import it. So we're importing all the libraries necessary. We've imported the data set. This is a data set somebody has shared with us. What you should do is you should say, hey, from scikit-learn.externals, right? Please import joblib. So we're going to import joblib. Now we'll say LBL is equal to joblib.load. So we're going to load the predictive model right now. Okay. So where is the predictive model? It's in the desktop, right? So I'll change the working directory to that guy now. Okay. So we need to load the label encoder right now. So what is the name of the label encoder? This is the name. We'll come back here. We'll ask him to load that guy. So label encoder has got loaded. Next is your standard scalar. That guy has to be loaded. So we'll say SC is equal to standard scalar. This guy has to get loaded. Next is what? Next is your PCA who should get loaded. Next is what? It's your SVM model who should get loaded. So PCA, I've already saved it. I did it in the month of June. Then this one is what? SVC. I've already saved it in the month of June again, SVC. So label encoder, standard scalar, PCA, and the classifier. All the 4 people have got loaded right now. Now you got your data set. Same thing. You need to go back and choose only the categorical columns right now. So we will go back and say, hey, these are the categorical columns. So let me just come back here and we'll paste it. So now we'll say, hey, these are the categorical columns. Please choose those people. These categorical columns should get transformed using the label encoder. So now we'll say, okay, so I've already imported the label encoder. Using that guy, I want you to transform these people. So he has transformed them. So you can see it's ready. Next is the numerical columns should get scaled right now. So we'll go back and choose only the numerical columns, which are these guys. Okay, so these are the numerical columns. They should get scaled right now. So where is that scaling code of ours? It's here, right? Now you can see we are asking him to scale it. So the standard scalar is already saved outside. We have loaded him also. Now we are asking him to scale it also. Now go back and look at the data. You can see everybody has got scaled. Now what would you do? You'll just concatenate them together. So your capital X right now is nothing but concatenating them together. So look at the capital X right now. You have 1000 rows and it should be 20 columns because looks like we are using the target. Target default shouldn't be here. Okay, so you can see the 1000 rows and the 20 columns is here, right? Checking balance, yes, checking balance should have been a categorical, so we can see that it has got transformed, and then you can see the numerical columns, they have also got basically scaled. So the capital X that you can see here, they have gone through all the transformation necessary for a categorical and numerical column. Now what should you do? You should use the PCA and transform this guy. So we'll say, hey, X of PCA is equal to, take up this PCA model and please only transform. Do not learn anything. I just want you to only transform my capital X. Now he has transformed it and you're getting what? Only 10 variables probably. So we can say, hey, this is equal to pd.data frame of this guy. So you'll right now have only 10 variables right now. 1000 rows and the 10 columns is here. Finally, what will you say? You'll say, hey, this is my support vector classifier. Can you please predict using these 10 PCs that we have? Let's hit Control Enter. He starts predicting for us. Okay. So this is exactly how we need to do it, guys. So this is on the training side. So during the training time, you imported some data set. You split them as predictors and targets. Then categorical columns went through label encoder. Numerical columns went through what? Standard scalar. Then you did PCA on the training data set. You created the model also on the training data set. So this was all done. What are the different things which are dependent on the training data set? One is, how did you encode the variables? That is very important. How did you scale the variables? That is also important because that is something that is dependent on the training data set. Then PCA, how did you transform them? Because this is also dependent on the training data set. Finally, the classifier you need it, right? So that you can use it in a later day. So the classifier is also important. 4 people we dumped outside. So we have dumped it in the month of June. Now you're waiting till August. Okay, just think that 2 months has passed. Right now you're in August. So in the month of August, somebody is giving us a data set. He says, hey, this is where my data set is. Please go and use it. Okay, he has given us the data set. Once again, categorical columns, numerical columns, etc. So what did you do? In the month of June, you might have done some encoding, right? That has got saved outside. You're loading him back once again. In the month of June, you would have used some mu and sigma to do x minus mu by sigma on each and every column. The same transformation should be kept. So you saved it in the month of June. You're loading it back again. PCA is once again another transformation. You did it in the month of June. You're loading it back again. Support vector classifier, you have saved it once. You're going to use the predictive model for the next 1 or 2 years. You're importing that guy also. So categorical columns went through the label encoder. Numerical columns went through the standard scalar operation. Together they became a data set, which you have transformed them using PCA, and then you are basically predicting, using these principal components. So this is exactly what will happen during the testing time. So I can save this code and I'll send it across to you guys. Testing code. So this is what will typically happen whenever it's in a testing phase. Not like testing, I would call it as predicting phase. Okay, whenever you want to predict it, this is what you should do. Whatever the training data set has gone through, the same things even the test data should go through. So if you're doing a standard scalar, do the same thing for this guy also. So let's go over again, guys. What did we do? In the month of June, somebody passed the data set. You did one kind of a label encoder. Then you did one kind of a standard scalar, right? Then you did a certain kind of a PCA, and you created a predictive model. So the predictive model understands only this encoding format, only this scaling format, and that PCA. So they're all dependent. So the PCA understood outcome coming from one kind of a scaling operation or one kind of a label encoding operation. Now, if you're in the month of August, you get a new data set. You need to push it through the same label encoder, the same standard scaler, the same PCA, same model, and get the predictions outside. Please do not make the mistake of doing a label encoder again, standard scaler again, PCA again. This is completely wrong. You shouldn't be doing it. Okay, you should not do this, guys. It's completely wrong. Because here the mean and standard deviation could have been what? 5 and 20. But here the mean and standard deviation could have become 25 and 400 probably. So you can't use this standard deviation and mean and push it to PCA. No, you can't do that. Already they would have fixed some scaling operation, right? The same scaling operation should happen. Please make sure that you're not doing this mistake, guys. So same data set, same label encoding, same scaling operation, same PCA to the same model to get the prediction for you. Okay. So this is your training phase, which happens in 1 month, and that is a testing phase, which happens in another month. So this is exactly the role of a PCA and how you should be doing all of these transformations together and push it to the predictive model and start getting your predictions here. Okay. Yes. Does it make sense, guys, still here? Are you able to follow how you should be doing it? There's a very important point. You know, understanding concepts is okay, but how do we practically do it is very important. You need to dump it outside and make sure that, you know, you can use it in another day, you know, when a new data set is arrived. Yes, did you all follow till here, guys? How we are dumping after finishing our training thing here, and then how are we using it during the testing time, that is during the prediction time? Yeah. Okay, perfect. So this thing stands for any kind of a transformation you will do, guys. You know, not just PCA. Let's say you do LDA, or you do, let's say, something called SNA, or, you know, not SNA. It's with another name. Or let's say this label encoder, standard scaler, or let's say if you're working with NLP tomorrow, if you're doing something called bag of words, right? Or let's say you're doing a bow vector or something, anything that you're going to talk about tomorrow, right? If there is some procedure you've followed for train, then please fix the same thing even for test. Do not change them. So the characteristics of the transformation should be kept as it is. Whatever you're keeping it for the train should be kept even for the test. You can't change it. That's a very important point. Great. So let me know, guys, if there's any questions. If there's no questions, I think we can just move on to Tableau. Okay, a very lighter topic, a beautiful BI tool. So we can move to Tableau if there's no questions here. Okay, perfect. Okay. So let's get started with Tableau. Yeah, that's okay, Srividya. So if you have a already installed version, it's completely fine. Okay. Okay. So let us first discuss, you know, why Tableau? Why are we discussing, you know, this Tableau as a BI tool here? Okay. Okay. So the very first question that we need to even ask before answering why Tableau is, what do you mean by business intelligence? So let me tell you, guys. So what we have today is, you know, or let's say till date, we have a lot of data that is available with us, right? So you understand that today there are a lot of sources where you can get some data, And there are, expert data engineers available today who actually make some very good software systems, and they try to get the data in some, very good format, in a very structured format. So let's say, for an example, if you have some data coming from, let's say some kind of a system logs or something. So these guys will make sure that they use some certain big data systems. They make sure that they kind of parse it. They bring it to a very neat format, and they can store it somewhere in what is called as a data lake. So what is a data lake? A data lake is basically the area where, the data is in a pretty normalized fashion, right? So data engineers, or let's say, data modelers, they do this particular work of playing with the data, bringing it to the right format, merging everything, whatever you need it. They'll give it to us, basically a ready to use kind of a data set. Most probably, sometimes even you may have to do the work, which usually happens most of the times. Okay. But most of the times, even you may have to do it. Sometimes, if you're lucky enough, you'll get some finished data. So the question was, companies were able to trap this particular data and they were able to store it somewhere, but they never really had this idea of making sense out of it. So how can we use these data to make some sense out of it? Say, for an example, I want to create a credit scoring model. How can I do it? So we just saw something, right? So we add some features, we add some variables, we have a target. You can create a statistical model, a machine learning model, go back and create some predictions out of something that's going to happen tomorrow. Or let's say, you're trying to design some campaign. You want to understand who might probably respond. So you want to go back and select the right members. Once again, you're using certain statistical models. So companies were not able to make sense of this particular data till date. Now, what we have today is the world where analytics is taking a very important position, where you want to start making sense out of this particular data. So you want to ask questions. Hey, what has happened? Why did it go wrong like this? What can we probably do? So you've started asking a lot of questions on the data. Guys, there's a thin line of difference between what is business intelligence and what is predictive modeling. Till date, we have been creating only predictive models. We are predictive modelers. We don't have to really jump into the core business a lot here. You really don't want to jump too much of the business. You just have to understand, okay, is this a variable? That's fine. I can go back and create a predictive model. I'm a statistical person. You don't really need to have too much of hold on what is a business here. There are usually business people who will consume the model and they will make sense out of it. But you as a predictive modeler, you need not worry too much of business, even though you need to have a small hold of it, but at least you need not have a very full-fledged hold of it. So business intelligence is a case where, guys, you start asking questions saying, hey, what happened? It's all something that you're answering for what is past already. Hey, what happened? Where did it happen? Why did it happen? So you're asking questions whichever has happened already. So if you ask questions to the past, that is what is called as business intelligence. If you're going to ask questions on what might happen in future, that is called as predictive modeling. Okay, where did we see a lot of sales? So which product has sold a lot? Which product did not sell? Which customers are very good? Why did we happen to see a lot of sales today? Whenever you start asking questions on the past, right, that is what is called as business intelligence. Well, if you start answering questions for the future, that is what is called as predictive modeling. So business intelligence is independent of predictive modeling, but predictive modeling is not independent of business intelligence. You still need to ask all of these questions. What has happened in past? Because only then you can start creating good variables. If you understand patterns available in the data set, then you can make use of them in your predictive models tomorrow also. So business intelligence is independent of predictive modeling, but predictive modeling is not independent of business intelligence, guys. So you need to still go back and ask questions on your data set so that you can convert them as variables which can be used in near future. So business intelligence typically is done using visuals, using graphs, visual intelligence as a tool. We go back and create a lot of charts. We try to make sense of what's happening at the back end. For which today you have what? You have a lot of, let's say, programming methodologies with which you can do it. Let's say you can use Python itself, Cbond, Matplotlib, or if you're using R, let's say ggplot2, or if you're using tools, people have been using something called Cognos, or people have been using Power BI, people have been using Tableau, ClickView, ClickSense. There are so many tools available in the market. Now for our class here, we're going to be talking about one of the tools, something called Tableau, which is pretty hot in the market. Okay, so typically whenever there's a data science profile, you can also see that they'll ask for one of the BI tool to be understood. Most popularly it is Tableau. Today it's Tableau which is taking a very good momentum. Okay, even though Power BI is trying to give it a good tough fight, but Tableau is still winning. Power BI has much more better features compared to Tableau, but still I'll say that Tableau is still winning the market today. So whenever you talk about Tableau, guys, there are 4 different products that we need to understand first. The first product is something called Tableau Desktop. So what is the first product? The first product under this entire Tableau thing is something called Tableau Desktop. That is number 1. Number 2 is something called Tableau Server. Number 3 is something called Tableau Reader. And over to the 4th case, we have something called Tableau Public. Okay. At a very broad level, we have 4 different products, guys. The first one is something called Tableau Desktop. The second one is called Tableau Server. The third one is something called Tableau Reader. And the 4th one is something called Tableau Public. So what do you mean by Tableau Desktop? So Tableau Desktop is actually speaking the workhorse of your entire Tableau suite of products here, guys. So basically Tableau Desktop is exactly what we've installed right now. He is the person who's going to help you create all the visuals, or let's say dashboards, etc. He's going to help you ask a lot of questions. He can help you do a little bit of data modeling also, even though it is not much recommended. And he's also going to help you kind of publish this particular workbooks online. So what is Tableau Desktop going to help us with? He's going to help us create workbooks, create dashboards, etc., publish them online also. What is Tableau Server? Tableau Server is exactly the area where you'll host all of this workbook. So basically you need to create a Tableau Server license, a project at the backend. And what you will do is, using Tableau Desktop, you can just sign into your account. You just have to say, hey, publish the workbook. They will get published to this server here, which means there'll be a small URL link. You can just visit this particular URL link and people can start looking at it. So collaboration is made easy. Unlike in Excel where you share your Excel spreadsheets to somebody, right? Here it's not required. You just have to share the URL to somebody. So they can just go back and access this URL and they'll be able to see all the dashboards here. That is the work of somebody called Tableau Server. Tableau Public is basically the same server, but actually speaking a free version. Okay, so Tableau Public, even it is including the desktop also. Okay, so Tableau Public that you see here is nothing but the desktop as well as the server, which comes as a free version. So Tableau Desktop comes with 15 days trial. And Tableau Server, I'm not very sure. I think it doesn't have any trial if I'm not wrong, but usually comes with a pretty high license cost. You need to buy a server also. Okay, I'm not very sure if it comes with a free version. Okay, but here I'm pretty sure it comes with 14-day trial, 14 or a 15-day trial. While in a Tableau Public, the server as well as the desktop comes with a free version. It's basically a free version, but they can't give you free, right? Even you can see the desktop is going to have all the properties, but he's costing it. But do you think he'll have the same kind of characteristics to come up with the free version? The answer is no. A lot of these features will be disabled. Many features will be disabled here, guys. So let's say if there are 100 features here, there will be only 10 features here. You can't create to a lot of data sources. Okay, when you want to publish your workbook, it is going to be available to the outside world. You can still hide it, but still I'm saying there is not enough security and all. So Tableau Public is actually speaking a free version of your Tableau Desktop and the Tableau Server. but still comes at a cost. He says that, I'm not going to give you all the features as it is like that. I'm still going to disable a lot of features. While Tableau Reader is another product, guys, what Tableau Reader will do is, example, if you have installed Tableau Desktop and you're creating workbooks, okay, when you're creating workbooks, if you don't have a server license where you can host these workbooks, what you can do is you can share the workbook with somebody and they can open the workbook using a Tableau Reader at free of cost. So what can they do? One is, guys, in a Tableau Desktop, people can create visualizations. They can create the workbooks, which means I can create a lot of queries. I can look at visualizations. I can choose which visual I want. I can do everything here in Tableau Desktop. I can share it with people in two fashions. One is I can save the workbook file and I can give it to somebody. They can open the workbook file either using Tableau Desktop if they have one, or they can open it free of cost using Tableau Reader. This is one method where we can save the Tableau workbook outside. Or in the second case, they can just publish it to a server and they can just access it using a URL. Right? So Tableau URL, Tableau server is exactly where you can host it. You'll get a URL which can be collaborated by a lot of people. Or otherwise, you can save it as a workbook, which can also be used by many people. A Tableau Desktop can use it, or a Tableau Reader can also read it. Then what is Tableau Public? Tableau Public is basically desktop plus server, which comes at free of cost. But a lot of features are going to get disabled. So there are 4 different products available in this Tableau, suite of products, guys. Tableau Desktop, Tableau Server, Tableau Reader, and Tableau Public. So we have 4 different products here. Now what we will do is, guys, we will basically start a discussion with Tableau Desktop. Okay, we are discussing only Tableau Desktop, by the way. So we're going to talk about Tableau Desktop. So as I told you all, it starts with 14 days trial. Tableau Desktop is always going to have 14 days trial. So what I gave you all actually implicitly is a method of beating the 4 days of trial. The 14 days of trial. So if you go back and install version 10.1, right, you'll get 14 days of trial. If you install 10.1.20 or something, you'll get another 14 days. 10.1.21, you get another 14 days. Then you can go to 10.2. Then you can go to 10.3. You can go to 10.4. You can go to 2018, 2019. So for every version that you see here, right, you will get 14 days of trial. So you can first use up all the 10.1 versions. So you can start from here, 10.1 till this one. There are easily 24 subversions. So 24 into 15, you easily have what? Somewhere around 150 plus days. Then you can use 10.2. You'll get another 150 days. 10.3, 10.4, 10.5, 2018, 12, 3, you can see 2019. So there are so many versions that you can keep installing for every fortnight, and you'll be getting 14 days of trial. So actually, implicitly, I've given you a method of beating the 14 trial problem. And why did I ask you to start from 10.1 specifically? The reason is because if you're saving a workbook in 10.1, it can be opened by all the new versions. So 10.2 can open, 10.3 can open. But if you do it at 2019 version, it cannot be opened by a 10.1 version, which means backward compatibility is not available. So something that I'm creating in an older version can be opened using a newer version, guys. But something that you're creating in a newer version cannot be used by an older version. So backward compatibility is not available. That is the reason why I asked you all to go back and install 10.1 version here, which means you get 14 days of trial for every version that you're installing. And I'm pretty sure, by the time the tool itself is going to be out of the market, there'll be another tool which might, probably be very, what I would say is popular. So I think it's enough time that you can, make use of these desktops itself. You can have all the features that you want to play with. Instead of that, you can install Tableau Public also, and don't take up the pains of installing for every 15 days, but it comes at a cost. You can't have all the features that you wanted. But if you want all the features, install this one for every 15 days. Okay, so you can install it for every 15 days and you will get what? You'll get 15 days of trial all the time. So this is how, you can use it for a long time and still practice this particular tool here. Okay. And I think server comes with a cost, right? So server is basically another product. I think you need to go back and install, and then, it comes with a cost if I'm not wrong, right? So Tableau Desktop, it's the workhorse that we see here, guys, right? So we're going to use this guy to, start creating all our workbooks here. So the moment you open Tableau Desktop, this is exactly how the home screen is going to look like. So the first thing the tool requires, it's a tool, by the way. Tableau Desktop is a tool which will help you create dashboards. The first thing that he's going to ask you is, hey, is there any data source that I can play with? Do you think you have a data source that I can make use of? We are saying, of course, yes. So if you need an access, so you have a lot of files, you can use an Excel file. You can read it from a text file, a JSON file, an Access file, a PDF, a Tableau server, a SQL server, Oracle server. How about something like MongoDB? Let's say, how about something like Hive, right? Google Analytics. So there are a lot of different data sources available here. You just need to make use of one of the data sources which is already available, or you can go back and make your own ODBC connection too. Okay, so you need to keep a data source, etc. here, then give him the drivers that he needs to make use of. Using this also, you can access, your connection. So you need to make your ODBC connections here. But before that, you need to configure your, data sources, etc. Right? So these are the different kinds of data sources available. In our case, it's going to be a CSV file. So I'll go to this more option. I'll go to desktop. So I have a data set already with me, something called sample store. We're going to import this particular sample store data set. It's a retail data set. So the moment we click it, you guys can see here, he has made a connection. So what has he done? He has made a connection. The connection's name is what? Sample store one copy. What sort of a connection has he made? He has made a Microsoft Excel connection. Okay, so he has a live connection, guys. He's reading the data coming from our data source that we created. Okay, so you can see here, it's actually a live connection. So the data source that we have, which is a Microsoft CSV file, he's having this connection and he's reading the data from there. And then he's saying, hey, on the inside, there are two sheets of data. Okay, I can open the sheet for you all. See, guys. Okay, so this is a data set. So here there is sheet 1 and here there is sheet 2. Okay, you want me to share the sample file right now? I think what you can do is, one, I've basically extracted this data, the Superstore data. So there should already be available a sample workbook here at the bottom. If you open Tableau Desktop, right, you'll be able to see something called sample workbook Superstore. You can open this one. I've exactly extracted that particular data only. It's the reason I've done it. So you can just open that guy. Okay, it has the same data. So now what you can do is, anything you want to play, you can play it here. So it has all the extracts, whatever is required. So for now, you can make use of this one, but I can still give you the final file, post the class is done. Okay. So there should already be a workbook that will come with, you can make use of that guy, something. Okay. But, post the class, I'll of course upload it in the drive. Okay. So what we have done here is, guys, we have basically chosen this particular CSV file and we have made a connection, right? So if you all open this particular Excel file, you'll be able to see that he's saying that there are two tabs of data. This is sheet 1, this is sheet 2. In sheet 1, you guys can see the different variables are these people, right? He's saying that, I have the segment, I have the ship date, even before that, I have the product name, how many days to ship actual, days to ship schedule, what is the discount that was given. So you have all the variables over here. Similarly, there is another smaller tab, another smaller table, which is having a variable like product name and a lot of other predictor variables here. A lot of other variables here. So what is common? Here product name is common, here also product name is common, right? The rest of the features are all unique. So these are all unique features. Even here, these are all unique features. So except for product name, everything else is a unique feature. I think region is also going to match. I made a duplicate for a region and region 1, okay? Here product name and product name, the names will match and is the exact column. So except for these two columns, everything is unique, guys. So what we have done is we have made a connection. There are two tables on the inside, sheet 1 and sheet 2. Sheet 1 is having, let's say, 10 variables or something. Sheet 2 is having another 5 variables or something. What we are going to do is, guys, we are going to do a little bit of data join right now. So now we are saying, okay, you've made the connection, right? I need to populate my data, for which we are going to take our sheet 1 and drag and release it here. What are we doing? We are taking our sheet 1, we are dragging it and releasing it here. The moment you drag and release it, you guys can see that it starts with product name, region, segment, ship date, and goes up to sales, sales forecast, and sales per customer. So these are the different variables that this sheet is probably having. Similarly, you can take up your sheet 2, drag and drop it here. Now between sheet 1 and sheet 2, it's going to do some kind of a join here. So what is he doing? With sheet 1 and sheet 2, he is going to do some kind of a join. So you can choose which kind of a join you want. An inner join, or do you want a left join? Do you want a right join? Or do you want a full outer join? We are saying, hey, I want an inner join using this variable, something called product name in the first table and product name in the second table here. So you can even think of it more like, I would say like even like a, SQL connection, let's say a database connection. So say for an example, I have a MySQL thing, okay? So I'll say localhost. So I have a local host running at 3306. The username should be admin. My password is hello@123. So we'll just say hit sign in. Okay. So he's going to try signing into my MySQL database. Okay. So there is no driver. I know this error. Okay. I'm sorry, guys. I don't think I can do this MySQL now. So there is a small error. So the driver mismatch. Let's try it once after logging in. But I think it should be a driver mismatch. Recently I was playing with it. Okay, let me try right now. Correct, yeah. So anyway, so actually I'm using a different driver. That's the problem. Okay, anyways. So you can just think of this as more like a database. Okay, this connection is more like a database that you're connecting to. And these are the tables that is available within that particular database, let's say. So sheet number 1 is one table, sheet number 2 is another table. You're taking up the two tables and you're trying to do some kind of a joining operation between them. What are the different options? He's having an inner join, he's having a left join, he's having a right join, he's having a full outer join. We are choosing our inner join right now. With this, the joining operation is done. So you can see that the data has got populated at the bottom. He's giving a small snapshot of the data, how the data is looking like. So he's saying, hey boss, there is a field called product name. If you don't like my name, you can double click and you can go back and rename it also. You can call it as product names, right? Or if you want me to sort the data set and have a look at it, there is an icon next to the name. Click it once, ascending order. Click it another time, descending order. Click it again, back to normal. Ascending, descending, back to normal. Ascending, descending, back to normal. So you're sorting this entire data set using this variable. You can edit the variable's name also if in case you want. What is the type of the variable that we are having? You guys can see here, this symbol will tell you at the top. He's saying ABC. ABC means what? It's a string variable. Here he's giving you a calendar icon, which means it's a date variable. Here he's giving a globe icon, which means it's a geographical location. Here he's saying it's a hash, which means it's a number that you see here. So what you guys can see here is we are dragging and dropping the tables. He's able to do a join here. He's quickly populating the data for us. He's telling, hey, this is how the data will look like, a quick snapshot. You can go back and change the names. You can sort them also, and you can change the data types also right now. You know, this is a string data type. This is probably a calendar data type. This is a geographical location. This is probably a number. So you have done data joins here. You get a snapshot of the data. You can also do type conversions right now. So say for an example, you don't want this to be a number. You want this to be a number decimal. You can change it. Now it will become 6.0. Or now you're saying, hey, let it be a whole number itself. So comes back to 6. So you can do all your data joins as well as type conversions, as well as edit the variable names, or even sort the data and have a look at it over here. So you're making a connection. Under the connection, there are certain tables. You're dragging and dropping the tables to do certain joins. Then you're getting a snapshot of the data. You get to edit the data, edit the name, change the column types, etc., etc. here. So I'm going to talk about these options also coming back in some time. You know, what do you mean by a live connection, a kickback connection? What are the filters available here? These are certain topics that we'll speak, you know, coming back in some time. So this window is called as a data source window, guys, where you've connected to one connection. You've made use of the tables to make some joins here. You have all the variables here. You have edited the variables names if in case you want. You see that Tableau is very smart enough to understand what should be the data types, right? So it has a engine at the back end, something called VizSQL, VIZSQL. VizSQL at the back end, who will infer what is going to be the data type of each and every column, and he's doing it for us. Now you can also type convert the data, you know, by just clicking this option and doing the same thing. This is exactly what the data source window has got to offer for us. Now, if this is done, then the data blending, the data joining step, everything is done. With this, you can just go back into the sheet to start creating all your visualizations here. If you think there is something going wrong, you want to make certain changes to the data source, you can click the data source window, come back, make some changes, go back to the sheet to create visualizations. So this is your data source window. This is your sheet that you're creating, a visualization that we are creating. Data source window, sheet, data source window, and sheet. So we are talking about Tableau Desktop here, guys. Tableau Desktop is the workhorse that's going to help us create all the visualizations and the dashboards for us. We just discussed about the data source window, where you can make connections to any kind of a data source. You want a MySQL, you want an Oracle, you want a SQL Server, anything that you like, you can do it. Then within that particular connection, if you have several tables, you can take up the tables and also do certain joining operations between them. It quickly populates the data here at the bottom. You get to change the variable names. You get to change variable types if required. If everything is good, then you can just go into the sheets that we see here, right? So using the sheets, this is exactly where we can start creating our visualizations right now. Till now, we were just doing what is called as our data prep. We were doing the data preparation required for making all these dashboards here, right? So any questions till here, guys? Till the data source window, is it good? You know, making a connection, doing a data join here. I'm assuming everybody knows what's a join because you guys might have come through your Python class, right? You would have discussed about joins there. I'm assuming you know what's a join. So once you're done with the join, once you're okay with the data, you're just coming inside the sheet to start creating our visualizations right now. Okay. Any questions on this one here? Till the data source window. You're good? Okay. So let's do something. Let's probably take a quick 10-minute break. Let's be a little strict, 10 minutes. Okay. So I think we can be back by 6:33. So Indian time it's 6:23. So let's be back in another 10 minutes, which will be 6:33. Okay. Thank you guys.
This conference will now be recorded.
Okay. So I think during the break I could have uploaded the file. I forgot. Sorry guys. Okay, so let's get started. Okay. So the next thing that we're going to start our discussion with is we'll try to understand, three keywords, three important things. The first one is we need to know what is a sheet here in a Tableau. Number two is we need to understand what do we mean by a dashboard. And the third one will be something called as a story. Okay. So let me go again. So the first one will be something called as a sheet. The second one would be called as a story. The third one will be a dashboard, or second one dashboard, third one a story. So what you guys can see here is once you're done with the data source window, guys, right? You can see here at the bottom that there are three buttons for us, right? So the first button, if you just hover over, he's going to tell us that, hey, I can help you create a new sheet. So the second guy is saying, hey, I can help you create a new dashboard. And the third guy is saying, I can help you create a new story. So there are three different fashions by which you can represent your numbers or your visualizations here. The first one being something called as a sheet, the second one being something called as a dashboard, and the third one being something called as a story. So what we are doing is, guys, you can see by default, there will be a sheet which will already get created. Okay, so there'll be a sheet already available. So you can see that you can just click this guy, or you can create a new sheet by clicking this particular icon, which will keep creating one sheet at a time. So we are clicking this icon, we can see that the sheet is already available. And you can see at the top here, he says that, hey, this particular sheet is having a data source. So you can see there's a tab called data, right? It's telling that this is a data source. What is a data source? It is nothing but sample store one hyphen copy, right? It's basically your sample store one CSV. So it is that particular guy, that is your data source here. And at the bottom, what you guys can see is he's giving us two windows. First window is something called dimension, and the second window is something called as a measure. Okay. So what we have is we have three entities, guys: a sheet, a a dashboard, and the third one being a story. A worksheet, a dashboard, and a story. In a sheet, what you can do is you can create only one visual at a time. A dashboard will be a collection of a lot of sheets, which means it can show a lot of visualizations at a single shot. A story is going to be a collection of a lot of sheets as well as the dashboards. So you see the hierarchy, right? So the first case is a sheet. A sheet can always create only one single visual. Okay, so you can see we have a one single visual. You create another sheet, you can probably go back and create another visual if you want. So one sheet will have one visual only. But a dashboard can contain multiple sheets, which is otherwise multiple visuals. A story can hold multiple sheets as well as multiple dashboards. So what can a story do? A story can go back and have multiple sheets as well as multiple dashboards. So that's how the hierarchy goes. Anyways, you're going to talk about dashboards and other people. For now, let's just be worried about something called as a sheet. So the moment you create a sheet, it's going to open a window that looks like this. And what you notice on the left hand side is one tab, something called as a data. It's going to tell us, hey, the data is coming from sheet 1 plus something else of your sample store 1 hyphen copy. Right click and you can look at the properties of it if you want. He's saying, hey, it's coming from desktop and this particular CSV file, or let's say Excel file. And just below that, there is one full box, something reserved for dimensions, and second full box reserved somebody called as measures. So what do we have? We have somebody called as dimensions, or dimensions can also be called as discrete variables. Basically, they are people who are more categorical in nature. They are discrete variables that you see here. While measures are basically variables which are more continuous in nature. So you have a variable set here, right? You have like 15, 20 variables. So all the 15, 20 variables will fall into either one of these two blocks that we see here. So the first block is for a dimension, which means it's for a categorical variable, while the second block is for a measure, which is more of a continuous numerical variable. Look at the cases. You can see product name. It should be a string, right? Categorical. That's why it came under dimension. Region, same, categorical. Segment, categorical. Ship date. Why is it categorical even though it is numbers? Because you can see it's all discrete. I can have only 1st June, 2nd June, 3rd June. I can't have 1.5 of June, right? So any variable that you see under the dimensions, guys, they're all basically what? Categorical or discrete in nature. While look at the measures, all the variables at the measures are all basically what? More continuous or numerical in nature. Example, days. Days can be even be 1.5. Discounts can be 1.23, 7.56. Profit can be $500, $500.6. Sales quantity, sales forecast, sales per customer. All of these people are more continuous in nature. That's why they fall under something called measures. While all of these people are more categorical in nature, that's why they fall under something called dimensions. So dimensions are categorical variable, measures are numerical variable. So all the variables that we see here will get segmented into either one of these two groups that we see here. So we understand what is a data tab doing. We understand what is the measure tab doing. It's giving us all the variables here, right? As well as a dimension tab. So this dimension tab, measure tab, we know what is all these variables, why are they getting populated here. So the next thing I want you all to understand is this one, a small tab for columns, a small tab for rows. So basically, guys, here in Tableau, there is not much of coding required. It's all fully automated, which means you just need to drag and drop something. He'll be able to quickly create your visualizations. Say for an example, somebody wants to understand the region-wide sum of sales. So somebody wants to understand what? The region-wide sum of sales. So what you could do is you could take up the region, which is a discrete variable, drag and drop it into columns. So what are we doing? We are taking up the region variable and we are dragging and dropping it into the columns that we see here. And what can we see? There are 4 regions on the inside: central, east, south, and west. See, he's showing all the regions in a column-wise fashion right now. Or drag and drop the same guy into the rows. You can see each and every region is shown in a row-wise fashion. So any variable that you're dropping into the columns will basically show the numbers in a column-wise fashion, or any variable that you're dropping into the rows, it's going to show its data in a row-wise fashion. So keep the region at the column, you can see all the values are in a column-wise fashion. Keep the region on the rows, you can see it's all in a region-wise fashion. Similarly, let's drag and drop something like sales. You can see that it is becoming sum of sales. It's getting aggregated. Why? Because he's saying there are so many different sale values. I don't think I can show all the sale values for you. So let me aggregate them by default. He's showing the sum of sales. So the first sale could have been for $10. Second sale could have been for $20. The third sale could have been for $1 million. So he's saying instead of me displaying each and every sale for you, why don't I aggregate all the numbers to give you something like sum of sales, which is happening by default. So the moment you drag and drop it, you can see that the axis is right now in a row-wise fashion because you dropped it into the rows. Now you can see the axis is more in a column-wise fashion because it's dropped in the columns. So axis is going in a column-wise fashion, axis is going in a row-wise fashion. Now you can see the same sale number, the sum of sale number is getting displayed in a column as well as rows. But what did we want? We wanted region-wise sum of sales. So we will say, okay, take up the region and drag and drop it here. Instead of giving me the sum of sales as a total number, why don't you segment it into different regions that we see here? So we're saying, hey, give me the sum of sales for each and every region. So the moment you drop it here, you guys can see that the single bar of sum of sales right now has become 4 bars because we have 4 regions over here. So this is what, let's say 0.3 million for central, you see 0.47 million for east, 0.26 million for south, 0.5 million for west. Whereas the total could have been what, 1.5 million here. Or, yes, it's 1.5 million if I'm not wrong, or 15 million. I think it's 15 million, whatever it is, right? So this would have been the individual sales, like, as you can see. I think we're making mistakes. So here itself is 3.6 million. 3.6, 4.7, 2.6, and 4.9. These are the individual total millions of sales in a respective region. If you remove it, the total sales is what? It's somewhere around 15 millions of sales that we are seeing here, right? So this is exactly how you can quickly create a small visualization, guys. And what you can see here is Tableau's this SQL at the engine at the back end is so smart that he will automatically understand what kind of a visualization are you probably interested in. So we just dragged and drop region-wise sum of sales, right? Immediately, what is he saying? He's saying, hey, I think a bar graph is very easier for you to kind of look at these numbers. I think probably that is what you want. So automatically, by default, he's creating a bar graph for us here, right? Now, I want you all to tell me. So how can I find, let's say, the segment twice maximum discounts we have given? Okay, let it not be maximum discounts. Let it be the sum of discounts itself. Okay, tell me, guys. Segment wise, I want to find profit. Let's do it for profit. Sorry. Segment wise, I want to understand what is the total profits we have earned. Can you all tell me how to do it? So we just have to drag and drop segment into columns or rows somewhere and profit here. So you get to understand what is the total profits for each and every segment, right? Isn't it? Or even you could have done something like this. You could have kept the segments in the rows and profits onto the columns. The same chart will be looking something like this, right? So also what you can do is, guys, just below the server option, right? Do you see a small swap symbol? When you click this, they will get swapped. So variables and columns will come to rows and variables and rows will go to columns. Swap, you can see. So here it's a column chart, while here it's a bar chart. This is called as what? A column chart, while this is called as a bar chart. So you can see that the bars are basically getting sort of swapped here, right? So this is exactly how we can quickly create a visualization, guys. You just have to drag and drop them. Now, say for an example, somebody might ask you a question saying, hey, for a particular region, for a particular segment, can you tell me what is the profit we have earned? So we'll say, hey, let's drag and drop region here. Let's drag and drop segment here. And let's ask what is the sales. So what is he saying? He's saying, hey, this is a central region, consumer, corporate, home office segments. East region, consumer, corporate, home office. Sorry, it's not home office, home supplies, home office only, correct. Similarly, south also you have consumer, corporate, home office. West also you have the same three things. Or you could have changed the order. Now it will be consumer, corporate, home office. Within that, you can look at each and every region, right? So segment-wise, region-wise sum of sales, or region-wise, segment-wise sum of sales, you can just interchange them however you want. So here we are finding region-wise, segment-wise sum of sales. Or you could have kept the segment here also if you want. Right? So segment will be in rows, regions will be in columns, and the sum of sales will be here. Or if you swap it, you can see segments is right now on columns, regions are probably on the rows. You can keep swapping them or interchanging them as how you like. So the dimensions here will basically divide your measures. They will give you the detail of the visualization. So dimensions will basically divide your visualization. Okay. So this is exactly how we quickly create a chart, guys. You just have to drag and drop a particular dimension or a measure that you want to visualize it. That's it. He'll be able to quickly create a chart for us. Now, I asked you all a small question, right? Saying, hey, can we find what was the maximum profit we have earned or the maximum sum of sales? Basically, the point is, guys, the aggregation here is sum, right? It's saying region-wise total profit. Now we are saying, hey, I don't want the total profit. I want the maximum profit I've earned. So aggregation should become maximum. It shouldn't be sum. It has to become maximum. So what we can do is, guys, you can see that there's an inverted triangle option, right? Also called as a caret symbol. If you click this guy, come down here, there's an option called measure. There you can probably make it as average if you want. Now we'll start giving you the average profits here. Or you can probably ask for the maximum profits right now. Or you can ask for the most minimal profit, which is otherwise losses that you have incurred. Or you can probably just come back and make it as sum. So by default, the aggregation is always sum, guys, but of course you can go back and change them also, by keeping it as probably average, median, count, min, max, anything that you like, and you see here. So what we're looking at here is basically region-wise sum of profit. If you want to make it as average, come back and change it here. It becomes average profit or maximum profit or probably minimum profit, which is otherwise the losses, right? So this is exactly how you can change your aggregations. Please understand that by default, the aggregations are sum. Why is he doing an aggregation? He's saying, hey, under the central region, I would have seen thousands of invoices, right? Each of these invoices will have a particular profit number. So I can't be showing each and every, profit value here. That's why he's saying it's better that I do an aggregation. So what's happening, guys? So within each and every region, there'll be so many different profit values, right? So first time I would have earned a profit of $10. Second time it would have been $15. Third time it would have been $45. So instead of showing each and every profit, he's saying I'm going to do the sum of profits. Now suppose in case, guys, you think that he shouldn't do this aggregation. You're saying, hey, please don't do the aggregation. Can you show me the individual numbers? In that case, guys, what you need to do is you need to go to this analysis option that you all see here. You see an analysis option, analysis, remove the aggregate measures. Now you can see there are all the individual profits that you can see. So by default, the aggregate measures is checked, which means he's saying, hey, I'm aggregating each and every measure for you. While if you uncheck it, he's saying, hey, I'm not aggregating them anymore. So this is one profit you have seen, $6,720. This is 1906. This is 1062. Comes down to minus 340. Choose all the people, hover over them. He'll tell you the sum is what? 0.8 million. Look at the analysis, aggregate measures. He's also saying the same thing, right? It's 0.8 million. So the point is, guys, if you remove the aggregate measures, you can see the individual data points. While if you switch on the aggregate measures, he's aggregating all the numbers to a single number right now. So if you all ask me a question, hey, can we please go back and look at each and every number without him doing the aggregates? Of course, yes. Go to this analysis option, uncheck it. But if you come back, then you just have to go back and check it once again. This is exactly how we switch on and we switch off our aggregate measures that's happening by default here. Okay. So this is exactly how we quickly create a visual, guys. It's all with, just dragging and dropping whatever we want to visualize. That's it. So the moment you drag and drop it, he's going to create some visuals by default. He thinks that, hey, this is a visual I think you're more interested in. So he'll create it by default. So if you guys notice this small marks card, we call it as a card. Okay, it's called marks card. You see an option called automatic, right? So he's saying automatically, I think you need a bar graph. So you can see there are 3 lines, right? So he's saying automatically, we guess that you need a bar graph. But suppose in case you say that bar graph is not very helpful, I want to show a pie chart. Then go to the show me option, guys. Click here, show me option. You have all the choices of charts that you want. Just go back and choose pie chart here. That's it. He has created a pie for us. Or probably you want to go back to the bar, you can go back and choose the bar again. Do you want a bubble? You can choose the bubble charts here. Do you want a tree map like this? You can choose the tree map. You want a single stacked bar? You can do a stacked bar. You want a heat map? You want a, let's say highlight table? You want a plain table? You want back to a pie chart? Do you want a bar chart again? You just have to choose the options that is available here. So look at a pie chart. He says, my requirements to create a pie chart are what? One dimension or one or more dimension, 1 or 2 measures. So what is he saying? He's saying I need 1 or more dimensions, 1 or 2 measures. If that is enough, if that is available, he can create the pie chart. So he'll get highlighted. I can't ask him to create an area because for area I need a date. I can't ask him to create a dual combination because I still need a date. For bar we need what? 0 or more dimensions or at least 1 measure. You can do bar, you can do stack bar, you can create table, you can create pie, you can create bubble. As far as the requirement is satisfied, you can literally do anything. But he thinks, hey, automatically, I think you need a bar here. That's exactly what the marks cards, the first drop down option is letting us know. Right? So any questions still here, guys? Do you all follow how to quickly create a small chart here in Tableau and how do we change all of these things? Do you all follow till here on how to create a quick chart? What are the columns you're doing? What are the rows you're doing? What is the meaning of dimensions? What is the meaning of measures? Do you all follow till here? Yeah? Okay, perfect. So the next thing that we're going to quickly discuss is, guys, so if you look at the marks card, right, this is basically called as a marks card. If you look at it, there are a couple of options available, right? What are the options? One is something called color. He's going to help you in coloring this particular visualization. Example, I can just hit this guy and go back and ask him to make it as orange. Let's say if it's in yellow, you call it as in yellow. Let's say, some kind of a maroon or red color. Let's say, some kind of a green or bluish color. Let's say a green color like this or a black color like this. You can just go back and choose the color that you want them to probably, create the graph with. So this is something called color. Now you have something called size. The size is going to decide the size of your bars or the pie, etc. Do you want it to be a horizontal line like this, or do you want it to be more, bigger bars like this? So you can go back and choose your bar size also by using the size option that we see here. Then we have something called as label. So what a label will do is, guys, it will start giving you labels on top of these bars that we see here. So I can just go to the label and I can switch on. So can you see? He's showing the sum of profit at the top of each and every bar that we see here. 0.8, 0.7, 0.4, 0.3 millions. He's giving you the labels at the top. I'll talk about detail in the next class probably. Then we have something called tooltip. What is the tooltip? If you just hover over the bar graph, you see a small box, right? It's saying region east and profit is 0.7 million. That is what is called as a tooltip. So whenever you hover over a graph, it gives you a small box, right? That's called as a tooltip that we see here. So we have a color, we have a size, we have a label, we have a tooltip. Now suppose in case you have a point like this, you're saying, hey, I don't want the colors to be uniform for all the bars that we see here. Central bar should take one color, east bar should take another color, south and west bar should take a different color. You're saying each of these bars should have one color. So what you can do is, guys, since the color is decided by the region that they fall into, you can choose region, drag and drop it into color right now. So what are we doing? We're saying, hey, the colors need not be uniform for all the bars. I want the colors to be decided by the region that the bar is basically belonging to. So what we can do is we can choose the region, drag and drop it into the color. So central bar will take one color, east bar one color, south bar one color, west is another. Now you can go to this legend here. You can say edit and you can keep changing. Now you say central has to be brown, east has to be probably gray, south has to be more like yellow. Then here you're saying it has to be purple. Let's hit apply, let's hit OK. So if the color of the visualization needs to be decided by a particular dimension, guys, you just have to drag and drop that particular dimension into this particular color option that we see here. In the same fashion, if you also want the size of the bar to be variant, it has to be decided by the region that they fall into. What you can do is you can take up the region and drag it into the size. So central region takes the least size, then the bigger size will be east, then followed by south, then will be west. So the size of each of these individual bars will be decided once again by the dimension that you're dragging and dropping them here. Or the labels that is getting displayed, even that should it be decided by a region, then drag and drop region into the label. So the labels will be the different regions that these bars fall into. So do you want them to also display something like sales or something? Drag and drop sales into the tooltip. Now you can see here, he's also showing the sales for you here in the tooltip. So any of these properties, if you guys think that it should probably be decided by a dimension or measure available in this visualization or in this data, you just have to drag and drop them here. Do you want the color to be decided by the profit that they have? So more profit, more intensity of color. Less profit, less intensity of color. Is that so you want? Take a profit, drag and drop it into color. Can you see? Since more profit, higher intensity. So little more lesser profit, so lesser intensity. Much more lesser profit, lesser intensity. Least profit, least intensity. I can go back and make the colors to be something like this. Right? So it's starting from green to orange. So you can see as per the intensity of the, based on the profit, the intensity of the colors are also getting kind of decided here. Similarly, the size also, do you want to get decided by the intensities? Drag and drop sum of sales to the size also. For different profits value, you can see that they're taking different sales. Do you want them to show the sales here, in the labels? Drag and drop them here. So you can see the different sale numbers here. Do you want the sale numbers to also be shown, let's say in the tooltip? You can drag and drop them into the tooltip also. So each of these properties, guys, can be decided by the dimension or the measure that you're using also. Okay, so drag and drop the dimension or the measure into one of these properties. You can see that they will control that particular characteristics right now. Okay, so this is color. This is something called size. This is something called label. This is tooltip. And this is how you swap them. We have spoken about it. The show me button is what you will use to probably change the different visuals that you want to probably create, right? And what you guys can see here is, this is a standard view, guys, which means it will occupy only small space. You can make it as entire view, which will occupy the complete space, okay? So this is fit width, which means in the width fashion fit them, fit height, height fit, Standard means both of it. Entire view means completely. We use an entire view so that it will occupy the complete space here. We make use of the complete space right now. Okay. So now I want you all to probably try a small problem at the back end. So I want you all to basically show category wise sum of sales. Okay. I want you all to display category wise sum of sales. Tell me how to do that. So let's go one point at a time. So let me know first. How do we do category wise sum of sales? Keep it pretty short, guys. You need not type, in full words. Just keep it pretty short and sweet. Okay. So dragging and dropping category here. Then we spoke about sales, right? So drag and drop sales here. So you get to know what is the category wise sum of sales. Okay. Now I'll tell you, this is a very interesting learning. Now I want to color them using subcategories. So what should I do? If I want to color them using subcategories, okay, beautiful. So now it's a very important point to notice, guys. See here, this is a plain bar chart. This is what? This is a regular bar chart that we create, right? So look at the category. There is a furniture category. There is an office supplies category. There is a technology category, right? So furniture category as a whole is probably having 5.2 millions of sales. Office supply is having 6.4 millions of sales. It goes to even to the last one. Now, suppose in case you want to drag and drop subcategory. What is subcategory, guys? Isn't it a division within the category? Which means in the furniture category, there are several subcategories. There could be 3 subcategories, 4, 5, 6, 7, 8, 9, 10. Any number of subcategories could be there. Now, what we will do is, look at this is very interesting. If you drag and drop category, he will say, hey, this entire bar is furniture, this entire bar is office supply, this entire bar is technology. But if we drag and drop subcategory, right? Now, important point is, within office supply itself, there will be several subcategories. So what is he going to do? He's going to divide this bar itself into several pieces. Even office supplies will get divided into several pieces. Look at it. We'll drag and drop subcategory into color. Now what you're ending up with is something called as a stacked bar chart. That is, I know the total sales of furniture is 5.2 million. But within furniture, I have subdivisions. Tables is one subcategory, furnishings is another, chair is another, bookcase is another. All of them constitute to the total furniture. So now he's dividing the individual bars that you see here into small segments. This is called as a stacked bar chart that we are creating. Previously, it was a plain bar chart. This is a stacked bar chart. So to create a stacked bar chart, ideally you will want what? You will want 2 dimensions. One of the guys should go into color. So now it becomes what is called as a stacked bar. So here we are creating a stacked bar chart. Similarly, I can drag and drop it into size. So depending upon different categories, it will take up different sizes. I can ask them to show it in the labels. I can ask them to show it in the tooltip, right? So this is exactly how you create what is called as a stacked bar chart, right? So this is how we are going to create what is called as a stacked bar chart, guys. Just drag and drop, the fields into the rows and the columns, and whatever be the fields it is required here in the colors or the size of the labels or the tooltips, That's it. He's going to start functioning. Okay. So I think with this, we are kind of done with, columns, and we are done with the marks card also. So we understand what will the colors option here do, what will the size, label, tooltip options would do. We'll come back onto the detail probably in the next class. Okay. So what do we have? We have dimensions, the various variables. We have measures. These are also, different kinds of measure variables that's available. Just drag and drop them and then start creating your visualizations here. Okay. So I think there's a question from Rakesh. So can't I drag subcategory in column with category and then put subcategory into color? So what are you doing there? You're basically creating many bar graphs. So you're saying till here it was category wise sum of sales. Then it becomes category wise, subcategory wise sum of sales. So there are so many bars. Now when you drag and drop it, everybody will be individual bars, colors. Now this is a different visualization altogether, right? So you're already displaying so many numbers, while this one will tell you composition. So this is too detailed, while this one will show it in a composition format. How are each and every bars getting composed? So there's a lot difference between keeping subcategory in the columns and not keeping them. So this is plain bar graph, while this becomes a stacked bar graph. So this will help you understand composition. Here it's more about comparison. Okay, so appliances in furniture versus appliances in office supplies. So it will help you do comparison. It doesn't help you do what is called composition. So this is more of a composition. Okay, of course you can do it, but there's a small difference between them. The visuals itself is changing a lot. Okay. Great. Okay. So the next thing that we'll quickly discuss is, guys, we'll look at what is something called as generated fields here in Tableau, or even before generated fields. Let's talk about something called hierarchies in Tableau. So in Tableau, we have a concept of something called hierarchy. So what do you mean by hierarchy? Basically, one level, more like a parent, then becomes a child, then there's another child. So all of them are sort of connected using some kind of a relationship, what we call as a hierarchy, right? So what we're going to do is, guys, you can see here, as what Rakesh just told me, right? So you can just go back and create a visualization like this: category, subcategory wise sum of sales. This looks good. Now suppose in case people don't want it by default, people by default want to see category wise sum of sales. When it is required, they can drill down. When not required, they can drill back. So you want to give people an option to drill down and drill back. Okay. So in those cases, we can create something called as hierarchies. How can you create hierarchies? Pretty simple, guys. We have subcategory, right? So we have subcategory. Just take him and drop him on top of category. So you can see here, it is kind of getting highlighted, right? Category at the back end. When you release it perfectly, only when you do it correctly, okay? Sometimes it may not work. If you, basically hover over everywhere here and then you go back, it will not work. So directly you should end up here within a few seconds. If you just, hover over everywhere, then later on, if you think you want to make a hierarchy, it will not work. So next second itself, it should go here. The moment you release it, he'll say, do you want to create a hierarchy? The name goes so. Now you can see there is a hierarchy, a tree kind of a symbol saying parent and child. So the topmost variable is category. Then on the inside, it's subcategory. You can drag and drop this hierarchy here and sum of sales here. Okay. So you can do what? Drag and drop this hierarchy and the sum of sales that we see here. So if a visualization is getting shown in a dashboard like this, so this is a dashboard which is having the visualization. Okay. What people can do is, guys, they can just come down here. There is a plus symbol. When they click it, it will drill down. So now it will show category wise, subcategory wise sum of sales. It will basically sort of drill down. When you go to the top and when you hit this minus symbol, it will drill back. So when you hit the plus symbol, it'll drill down. When you hit the minus symbol, it'll drill back. So hierarchy, drill down, hierarchy, drill back. So this is the work of a hierarchy. If you're not probably creating a hierarchy, let me remove the hierarchy. If you don't create a hierarchy, the chart is going to be default like this. You don't have any drill down or drill back option. Can you see? We don't have any of those things. It'll be constant as it is like this. It's static. Whereas if you have created a hierarchy, then it's a different story altogether. You can go back and drill back whenever it's required. You can drill down whenever it's required. So drill down and drill back option is typically given when you create something called as a hierarchy here. Okay. So why don't you guys try something? So do this. Within a particular region, within a particular segment, try to find the sum of sales and try to create it as a hierarchy, region and segment. So I'll wait for a minute. Why don't you guys just try to do it at the back end? So region and segment should basically become a hierarchy. And I want to understand what is the sum of sales, or let's do average sales. Create the hierarchy. The hierarchy will basically display the average sales. Just let me know once you guys are done, then I'll try it. Cool. So what did you guys do? Drag and drop segment onto the region. Hit OK. You would have created a hierarchy here at the bottom. Drag and drop the hierarchy here. And drag and drop something like sales over here. But we wanted average sale. You would have gone here and done it as average. Right? So drag and drop segment onto the region, create the hierarchy, drag and drop the hierarchy here, drag and drop sales here, which comes by default as sum of sales. You can just go back and make it as average sales. Right? So now this is what the average sale numbers for a particular region. Drill down to get region wise, segment wise average sales. Drill back to get only region wise average sales. Drill down, drill back. So this is exactly how you function with a hierarchy here in Tableau. Right? So another smaller topic. So what we have just discussed is something called as a hierarchy. Okay. So the next topic that we'll quickly discuss is, guys, if everybody is okay and if there's no questions, let's jump into something called as generated fields. Okay. So we're talking all the functionalities available within dimensions and measures. Okay, let's complete that. Then we can go on to the next ones. So we're talking about something called generated fields in Tableau. What do you mean by generated fields? It's a automatically created field by Tableau. So Tableau is creating that particular field. It was created by Tableau. That's called as generated field. What are the different generated fields we have? We have something called measure value. Sorry, guys. So you can see measure value. He's saying, hey, it's a generated field. You can go to measure names. He's also saying it's a generated field. You can go to number of records. He's saying it's a generated field. Latitude and longitude, they are also generated fields. So there are 5 fields which are not part of your data set that you had originally. These are basically variables or fields which were created by Tableau. It was created by Tableau here. Those are measure names, measure values, number of records, latitude and longitude. So let's start a discussion with number of records. Now say for an example, guys, somebody might ask you a question. They are saying, hey, can you please let me know how many transaction has happened in a particular region? So they're saying what? Hey, we have 4 regions, right? Can you please let me know how many transactions has happened at each and every region? So what can you do? You can take a region, drag and drop him here. He's displaying all the 4 regions for us: central, east, south, and west. You can drag and drop the same region down here and go back and make a aggregate function, something like count. So what are you saying? You're saying for every region value that you see, that is central, east, south, and west, can you please just count them? How many times do you have central? How many times do you have east? How many times south and west? He's saying 29,000 central, 32,000 east, 19,000 south, 34,000 west. So he's giving you the count of each and every times this particular region value was actually met. He's giving the count. He's telling you, hey, these are the number of times I saw this particular region value. So you're dragging and dropping that guy and you're saying that it's a count. But instead of doing a long way like this, guys, Python is saying there's a much more shorter method. What is the shorter method? You see number of records, right? You can drag and drop number of records to this particular guy. That's all. He's also doing the same thing. He's saying, hey, we are going back and counting how many records did we see which belong to the central region, how many records at east, west, and south regions respectively. Instead of going back and counting them individually so many number of times, we can just go back and count how many number of records do we have at each and every region here. That's all. Right? So instead of doing count of region, we can just go back and say, hey, let's go back and count the number of records here. So it's the same thing. The number of records is a generated field which is created by Tableau, which will let you know how many counts do we have for each and every case here. So similarly, guys, what you can do is, I'll tell you, you can sort this entire diagram also. Okay, so let's say this is a field that you have, right? Do you see there's an option here to sort? Click once, ascending order it should be usually, but here is descending. I don't know. So probably here it's descending. Click it again, ascending. Click it again, comes back to normal. So descending, ascending, normal. So it's sorting the regions, right, based on the count that we see here. So now he's saying, hey, the regions are west, east, central, south, because west is having the highest number of times. Whereas here he's saying south, central, east, and west, because south is having the least. Now it comes back to normal. So you're basically sorting this entire visualization here, guys. You can do it in many fashions. You can go here and also ask them to sort it, right? So you can tell them, do you want to do it based on a field, whatever it is, or you can sort it by clicking it here also. Now a small exercise to you all. So can you all please let me know the top 2 customers who have purchased many number of times? Can you all give me the names of the top 2 customers who have purchased many number of times? So the field is something called customer name. It should be with you. See here, customer name. So I want you all to please fetch the top 2 customer names, or the names of the top 2 customers who have purchased many number of times. Okay, who are the 2 guys? So you're saying it's somebody. I seriously can't pronounce those guys' names. Anyways, in my case, how we would have done is drag and drop customer name here. Then what? Number of records, right? So we just have to go back and ask for the total number of times that they've purchased. Nizam, it's not maximum. Okay, I think you just have to do sum of number of records. Okay, so you don't have to keep a max and all here. Okay, so max will just say 1. So you have to keep it as sum. So it'll tell you how many number of times did they probably purchase. So now, it's all jumbled. So what I can probably do is I can just go back and sort this guy, right? So we can just, if I've kept it here, it would have been easier. So we can just keep this guy and go back and sort it. So now we'll say, hey, click this, descending order sort, click this again, ascending order sort, click this again, back to normal. We want descending. So this is the first customer. In my case, it's somebody called Matt, and then it's somebody called Cynthia. I have these two people, my data. I don't know about your cases. So in our case, it's somebody called Matt here and another person called Cynthia. Right? So this is exactly how you should be doing. You should be dragging and dropping customer name here, number of records over here, then just sorted in descending order. You have the top customer Matt and the second top customer Cynthia. These are the two people who have been purchasing many number of times. How many times? So this customer has visited 854 times, while this customer has visited 771 times. Right? So this is exactly how we get the counts of the number of times that these guys have probably purchased with us. Right? Okay, perfect. So any questions till here, guys? Are you all okay till here on this particular portion? I'm going to talk more about this generated fields probably another day, because measure names and measure values is a little too early to start discussing now. I'll talk about measure names and measure values probably in the next class. Any questions otherwise till here? Clear? Okay. Okay, perfect. So just give me 2 minutes. Okay, so I'm just gonna be back. Okay, let's probably take a quick 2-minute break. Okay, and just let's be back. Yeah. Okay, so I think we can resume. Okay. So yeah, what else is left? So we have spoken about the data tab. We know what's a dimension. We know what's a measure. We've spoken about generated fields. We've spoken about the marks card, color size, text tooltip. Yeah. Then I think we can probably start with certain, continuous graphs. Let's go back and create certain line charts. Okay. More something related to dates. So the next thing that we're going to do is, guys, we're going to create certain, continuous graphs. more like, the accesses are more continuous in nature instead of them being discrete in nature. Because you can see bar graphs and all is more discrete in nature, right? Line charts are all more continuous in nature. Let's try to create something on those lines. So you can see here, guys, just like how continuous variables or measures like these people are getting sort of aggregated, min, max, average, sum, they're kind of getting aggregated. Even dates here in Tableau will sort of get aggregated. You see it? So we drag and drop something like order date, right? We can see that the order date is also sort of getting kind of aggregated here, right? So we can see that, it's probably taking year of order date. What you can also do is, if you just come to the bottom, right? If you just click this, inverted triangle, come to the bottom, you have a lot of other options. Say for an example, let's look at the yearly sales. You can see it has become continuous chart. Why? Because it's all date, right? So it's all continuous. So that's why it has become continuous chart. If you click at the bottom, you have other options, like you can make it as a quarterly view if you want, Q1, Q2, Q3, Q4, or you can make it as a monthly granularity, which is Jan, Feb goes up to December. By the way, guys, this data is starting from 2011 itself, 11 till 14. So 2011, 12, 13, 14, because you've chosen year. This is Q1, Q2, Q3, Q4, where this Q1 is an aggregated number for 15 Q1, 16 Q1, 17 Q1. All the Q1s together, irrespective of what will be the year, it's talking about Q1, that's it. Similarly, if you make it as month, right, it's January month, which might include what? 2014, 15, 16, 17, everybody together. By the end of the day, it's a January month. Here it's day 1 to 31. So every day for the last 6 or 7 years, how has the sales been going? You can ask for the average sales. So you can see for the last 6 years, on every 8th day, my sales are going up. And on the every 16th, 18th, 17th days, my sales are going up. And it's going down on the every 13th day. On the every 21st day, it's going down. Or across all the years, give me a monthly performance. So for every February, the sales is going down. Every July, my sales is shooting up. Every March also my sales is shooting up. Every September also my sales is shooting up. Literally for every year, right? So you can go for quarters. So I see that every Q3, I'm getting more amount of sales. Q2, it's not much. So I think I should be running some kind of discounts to promote more amount of purchases for people to do. So this is all across the years, guys, on the full data. Well, the same fashion, you have it here at the bottom. Quarter, you see another option, but this one is every quarter for every year. Can you see? 2011 Q1, 2011 Q2, 2011 Q3, 2012 Q1, 2013 Q1. Similarly, month. So if you go to month, he'll say, hey, 2010th month, 2012th month, 2013th month, each and every year, each and every month is getting displayed here, right? Similarly, week number, we have what, 51 weeks or something, right? For every week, he will show it to you. Days, for every single day, he's going to do it for us. Or you can make it as something called exact date, which will tell you the perfect granularity as however your data is available. If your data is available at a timestamp also, he'll show it including the timestamp. So that's the last option, something called exact date here. So these are the different kinds of aggregations which will happen on a date data type, guys. So we have a year, we have quarter, we have month, day, this kind of year, quarter, month, week number, days, etc. So many different options available here, right? So suppose in case somebody is asking, hey, can you let me know what is the monthly wise sum of sales, right? I just have to take up something like ship date here, go back, make it as month, then you can just drag and drop sum of sales, right? So you get, okay, ship date is only for 17, I guess, right? So you can probably go to order date, drag and drop them here, make it as probably month or something. Now you can see for every month, for every year, you get to see what is the sum of sales here, right? So this is how you basically go back and create a chart. So automatically your Tableau is saying that I think you need a line chart. If you want to make it as a bar also, you can drop it and make it as a bar here. You can make it as an area also if you want, right? You can make it as something else also you want. You want a pie chart, you can make it as a pie chart, right? So you can change the type also by going back and changing it in the show me button that you see here, by keeping it as an area, or by keeping it as a line here, or by keeping it as a pie here. So you can do it from here also. You can go back and say, hey, probably make it as a pie, or probably make it as an area, probably make it as a line. So you can change them from here also. Make it as a bar, or make it as a bar like this, right? So these are the different options available, guys, right? So any questions here on this topic? Dates, how to play with dates, the aggregations on the dates. Okay, perfect. Yeah, so I think we can just extend for another 10 minutes, guys. With that, let's probably call it a day. So the next quick thing that we can probably discuss about is, let's say something called filters. Let's talk about filters, okay? So the next quick topic that we're going to talk about is something called as filters. So what do you mean by filters? As the name says, filters is nothing but you're adding some kind of removal or kind of inclusions of data here. So you're basically trying to do what? Filter some data, keep it or remove the data here. So what you can do is, guys, say for an example, you have something like region that we're dealing with, right? So let's drag and drop region here. Let's drag and drop sum of sales here. Now, probably you don't want to display all the bars. So you want to probably just show it for central and east. So you're saying, please filter out south and west. I don't want to see those people. I want to display it to my regional manager, only the central and east regions. So what you guys can probably do is, let's create something called as a quick filter, guys. So we are talking about something called as quick filter right now. So there are 6 to 7 different kinds of filters we can create. Let me give you all the names. One of the first filters that we can create is something called as an extract filter. Number 2 is something called as data source filter. Number 3 is something called a dimension filter. Okay. Number 4 is something called as a continuous filter. Number 5, quick filter. Sometimes quick filter is elaborated to many other types. Sometimes people would like to write something called exclusions filter and inclusions filter. But I call it at a very high level topic, something called quick filter. Then you can have something called action filters. Okay. 7, is there anything else? Quick filters, dimensions. I think this should do it. Okay. So we have extract filter, we have data source filter, context. I missed context. So 7th one is something called context filter. So we have extract, we have data source, we have dimension, we have continuous. Within quick, we have exclusions and inclusions. We have action filters, and then over to the last one, something called context filter. So we basically have 7 different filter options here. So we are talking about filter here. So the point was what? We have 4 different bars available. We just want to display the central and east. We don't want the south and west. So what we can do is, guys, we can go back and choose only these 2 bars by choosing your control keyboard on the keyboard. Go back and choose these 2 bars. Hover over this particular guy. Now you'll get an option saying keep only or exclude. When you mean by keep only, it means what? Which means include these 2 people, remove the other guys. So you can see it's what? It's called as an inclusions filter, actually speaking. It's doing what? It's including these 2 people. Whereas if you say, hey, south and west need not be displayed, so you're choosing these 2 people, you hover over, there's an option to exclude. When you click this guy, he says it's an exclusion filter right now. I don't know why it's not giving the names, but usually they will give you a name. Okay, it's called inclusions and it's called exclusions. I know, probably because of version or some other case. I'm not very sure. Let's do something category here. Now you can see, yeah, it's exclusions. I doubted. So for more than a single variable, it'll start calling it as exclusions. So you can see here it's excluding it. While now you're saying, hey, keep these 4 people or 2 people, now it will become inclusions filter. So when you want only these bars all to be retained, you choose them, you go back and hover over, you say, hey, just include these people, keep only these people, it's called inclusions filter. Whereas if you say, hey, hover over and exclude, it becomes exclusions filter. Inclusions and exclusions. Okay, so this is an inclusion filter and exclusion filter. And this is at a broad level concept, it's called as a quick filter, because you're just quickly going back and choosing the graph and you're including and excluding the levels that you want. That's why it's called as quick filters here. Okay, so I hope quick filters is okay for you all, right? So the next thing that we'll quickly discuss is probably a dimension filter. Okay, so what you can see is, guys, let's just go back to the diagram here. We had the region, right? So we chose this guy and we said, hey, keep only this fellow here. Or we said, we chose this guy and we're saying, hey, exclude only this particular guy here. Actually, guys, since you are filtering using a dimension variable, somebody like region. So you're saying, hey, keep the central region. Now you're saying, hey, remove the central region. Since you're doing the filtering operation using a variable, something like region, which is a dimension, any filters you're creating using dimensions are called as dimension filters. Or any filter you'll probably create with a continuous variable is called as a continuous filter. So what are we doing? We're going back and saying, hey, keep only this guy. So it becomes what? A inclusions filter, or since you're using region, it becomes a dimension filter. What you guys can do is, you can quickly do a right click here and say show filter. And all the filtering operations can come out here as a UI. You can just go back and say, hey, show east also for me. Hey, show south also for me. Show west also for me. Or now you can just uncheck these people. Now you're saying, hey, include south also, include west also. Or on the opposite, if you go back and say exclude, now go back and show the filter. So when you say right click and show the filter, right? So any person that you're choosing will basically get excluded right now. So the difference is, guys, in the previous case, they were getting included, right? So I can just go back and remove this guy. If I remove it, now I'll say, hey, keep only. So now it's an inclusion type. So now you're including the levels that you want, right? But whenever you check, you're including the level you want. While here, it's an exclusion filter. Why? Because you're excluding the level that you don't want, right? And since you're doing it using a dimension, it's called as a dimension filter right now. So any filtering operation that you're going to do with a dimension is called as a dimension filter. Any filtering operation that you're doing with a continuous variable is called as a continuous filter here, right? So to know more about it, you can do a right click and edit filter also. Can you see? He's saying these are the general options. There are several options, guys. We'll deep dive in probably in the next class. So there's a general, there's wildcard, there's condition, there is stop. Let's go to general. Under general, you have 3 options: select from list, custom value list, use all. So let's go to select from list. So what we are saying is, you're saying, hey, whatever I'm selecting in the list, right, they should be displayed. Okay, so by the way, it's working a little differently. I'll tell you why. Okay, so let's drag and drop region here. You can see he opens the box. So you're saying general, select from list. Whatever I'm choosing from the particular list, they should be displayed. Can you see at the back end? He's displaying only central and east. We'll choose south also, he'll display. We'll choose west also, he'll display. So this is inclusions type. Whereas when you activate exclude, whatever you're choosing will get excluded. Go back and uncheck these two people. So you can see only central and east are getting excluded. Choose south also, even south will get excluded. Choose west also, even west will get excluded. So the difference is here it's an inclusion type right now, whereas now it's an exclusion type here. You can just change it by, switching this exclude option here. When you check it, it will become exclusion type. When you uncheck it, it will become an inclusion type here. So, include filter, exclude filter, they are once again getting worked using your dimensions that you see here. So you can just drag and drop your dimension here, select from list. You can go back and choose anything from the list that you want to be displayed, or you can choose anything from the list which you want to get excluded. You can just, choose them from this particular list that you see here. Next is called custom value list, which means you can type it. So you can say, hey, include West also. Hit apply, you can see West is also getting removed. Or use all means remove everybody. Or, choose everybody. That is the meaning. Okay. So this is a general option, guys, where you can select from the list available here. But probably if it's not available in the list, but may come tomorrow, then you can go and add your custom values. But if you probably want to use everything, then you can just go back and say use all. Since you're doing a filtering operation using a dimension, it's called as a dimension filter here. So there are more options to speak about a dimension filter. Example, what is wildcard, what is condition, what is top, which ideally we'll probably take it from the next class onwards. Okay. So what we have quickly discussed is, we have spoken about the data tab that we see here. We have spoken about the dimensions. We have spoken about measures, how to drag and drop each of these fields here to create the different visuals we want. How can we go back to the show me button and we can keep changing the different visuals, right? And what else did we discuss? We have spoken about the marks card. What is the role of the color, size, label, tooltip, all of these, properties that we see here, right? And how can we do the filtering operations by using what? A dimension or a measure that we see here. Measure we still haven't spoken about, but I'm just saying, with using any measure or dimension, you can create any type of filter that we see here. There are 7 types of filters that we have, just noted down. So any questions till here, guys? Are you all okay following till here? I'm sorry, guys, my voice is not at the best today. That's why I want to kind of close it a little early. Yeah. Following till here? Okay. Okay, perfect. Okay, so I think with this, we can probably call it a day. Yeah. So what we can do is, probably in the next class, once again, we can just go back to Tableau again. Then, on Sunday's class, we'll once again have a little bit of Tableau probably. Then we can, discuss time series forecasting. That's a beautiful, small, interesting topic. I think that's probably going to be the agenda for our next class. Okay. So otherwise, yeah, thank you guys. Thanks for joining. I'll make sure that the videos are online by tomorrow, afternoon or something Indian time. Yeah. Thank you guys. Let's catch up in the next class.